Greetings to everyone. Today we are going to discuss the next topic in pericyclic reaction, that is electrocyclic reaction. See, electrocyclic reaction is a molecular rearrangement that involves the formation of a sigma bond between the termini of a fully conjugated linear pi-electron system. You remember that it is a fully conjugated, not partially, it is a fully conjugated linear pi-electron system. It is not a non-linear, it is linear pi-electron system or a linear fragment of a pi-electron system, whatever it is. And a decrease by 1 in number of pi bonds. Here, a formation of new sigma bond is taking place and one of the pi bond, the number of pi bonds in the reactant molecule are decreased in the product, or else the reverse. That means new pi bond may be formed and one of the sigma bond may be disappeared. Such type of reactions are generally called as electrocyclic reactions. Now, let us see some of the examples in connection with this. Here, if you see, this is a molecule. Here, 1, 2, 3, 4, 5, 6. This is 1, 3, 5. That is 1, 3, 5 hexatriene. This is a linear pi-electron conjugated pi-electron system. Now this one, it is undergoing electrocyclic ring closure. See here, the bonds, how they are shifting. The pair of electrons are shifting here, and this pair of electrons shift here, and this pair of electrons are shifting here, suppose. You can see a new pi bond is formed in between these two carbons. Here, this is a new pi bond. And here a new pi bond is formed in this between these two carbons, see, new pi bond. And this pi bond here in this case is not available in this case. But you can see there is a new sigma bond is formed between these two termini. Here in this case, this is the two termini. And a new sigma bond is formed. Now this is a forward reaction. Suppose if you see the backward reaction in this case. See, let us see first of all, number of pi bonds, how many are there? 1, 2. Number of pi bonds, how many are there? 1, 2, 3 pi bonds are there. In the product, only 2 pi bonds are there. But a new sigma bond is formed. In the reverse reaction, if you see, number of pi bonds, how many are there? 2 pi bonds, and here in this case 3 pi bonds. This sigma bond is disappeared. Okay, this is the forward and backward, both are called as electrocyclic reactions. Since this one, the reactant is undergoing closure, this is called as, the forward reaction is called as electrocyclic ring closure, while this molecule is undergoing ring opening, so the backward is called as electrocyclic ring opening. Very simple. The forward is called as electrocyclic ring closure because it is undergoing closure. Okay. The backward is called as electrocyclic ring opening. Both are electrocyclic reactions. Okay. In general, you can see. Okay, this is the pi bonds are in delocalization. Okay, you can say this is a partial delocalization of pi bonds. You can represent like this. Then, suppose if it is a charged molecule, okay, you can write it like this. And we can experience a molecule like this, a product like this, where a new sigma bond is formed in this case. Okay, the pi bonds may delocalize at any one of these two positions. Okay, either this position or this position. Okay, if the pi bonds are delocalizing with a charge, okay, you can experience a charge here. Okay, so this is what you call electrocyclic reactions. And coming to the stereochemistry of electrocyclic reactions, this is very important. The stereochemistry of such a process is termed conrotatory or antarafacial if the substituents on the interacting termini of the conjugated system both are rotating in the same sense or same direction. Let us see, what does it mean? Conrotation, suppose this is a molecule, okay, and at this end, okay, at one of this end, okay, so at one of this termini you have a methyl group here, and another termini also you have a methyl group. See, if this termini is rotated in an anti-clockwise direction, whereas this termini is also rotated anti-clockwise direction, So this methyl group goes downside, this methyl group which is in plane goes upside. Okay, this is upside and this is downside. And you can see these two termini, okay, these two termini are rotated towards the same side. Both are rotated anti-clockwise. Both are rotated anti-clockwise. And here in this case, why it is called as antarafacial means when a sigma bond is formed at the termini, okay, this is the termini, in between these two termini, new sigma bond is formed. This new sigma bond is formed by the overlap of orbitals which are present on the opposite faces, okay, which you call as antarafacial, opposite faces interacting to form a new sigma bond. When the opposite faces interacting to form a new sigma bond, then the substituents in this case, here in this case, you can see these two substituents which are outside, okay, they are on the opposite sense, okay, opposite to each other. Okay, so the stereochemistry of such a process in this case is called as, this rotation is what we call con rotation, or the process is called as con rotatory process. Okay. So is it clear? The stereochemistry of such a process is termed con rotatory or antarafacial if the substituents, okay, here these are the substituents, okay, if the substituents at the termini, okay, at the interacting termini, these two are the interacting termini, these are the substituents. So if the substituents at the interacting termini are rotated, okay, both rotated on the same sense direction, okay, here both the substituents are rotated in a anti-clockwise direction, either it may be anti-clockwise or clockwise. Here both are rotated anti-clockwise, okay, this is anti-clockwise and this is also anti-clockwise. So such a type of rotation of the termini is what we call con rotation, okay. And you can also have this one, both you can rotate in a clockwise also, this can also rotate in a clockwise. If you rotate this one clockwise, if this methyl group goes downside, if you rotate this one clockwise, this methyl group goes upside, this is down up. If it is anti-clockwise, this down and this is upside, okay, that means upside of the selected plane. So this stereochemistry of stereochemistry of a process uh, is termed con-rotatory or antarafacial if the substituents at the interacting termini of the conjugated system are rotated in the same sense. Is it clear? Next, coming to next. So coming to the disrotatory or suprafacial. If the terminus of the molecule, okay, a continuous conjugated 5-electron system rotated in a clockwise or anti-clockwise, then one is clockwise and the other is anti-clockwise. Okay, then that type of rotation is what we call disrotatory. Okay, when a sigma bond is formed in this case, this sigma bond is formed by the interaction of the orbitals. In this case, this is our orbital and this is the orbitals. So same side lobes, that means same phase lobes will interact together to form this new sigma bond. That is what we call suprafacial. Okay, and the termini in this case, one rotated clockwise and the other rotated anti-clockwise in this case. So this is called as disrotatory or suprafacial if one of the terminals rotated clockwise and the other terminus rotated anti-clockwise. Okay, so this is called as disrotatory electrocyclization. Suppose in this case, if you see this is rotated clockwise, then this methyl group comes downside, and this is rotated anti-clockwise, this methyl group comes downside. Okay, this is the stereochemistry. Both are alpha, that means downside, okay, to the this sigma bond. This is called as S cis. With respect to sigma bond, both these two methyl groups are aligned on the same side, S cis type. Suppose if you rotated this one anti-clockwise, suppose if you rotated this anti-clockwise, and this one clockwise, then you can see this methyl group goes upside and this methyl group goes upside. Okay, so this is what we call disrotatory. Okay, so you can have another stereochemistry where methyl group are projecting upside and these two methyl groups are projecting upside. Okay, with respect to this sigma bond, even this can be called as disrotatory. Okay, so is it clear regarding what is con rotation and what is disrotation in electrocyclic reactions? Okay, so in the next class we will discuss a wide variety of substituents wide variety of molecules and how con and dis rotation will take place in them.